All right, let's go ahead and break this problem up. It says a bacterial culture contains 5,000 bacteria and the number of bacteria doubles each day. How many bacteria will be in the culture after a week? So what I'm going to do is just break this up. So I see 5,000 bacteria and the number of bacteria, it doubles each day. So each day it doubles. How many bacteria will be in the culture after a week? So after a week, how many will be in that culture? So from here, what I can do is actually just write an equation or a function for an exponential function. So let's get started. All right, so the first way I'm going to think about this is as the form of an exponential function. F of x is equal to, well, a1, I'm going to fix that, a1 times r raised to the power of x here. So now I'm going to take this information and just think about the relationship of this function to the problem above, and I'm going to try to write it as a function in words. That might be helpful. So f of x, this is representing our output. In our output here, we're asked how many bacteria will be in the culture after a week. So I'm going to just say that f of x, I'm going to think about that as bacteria, and let's fix that I there, bacteria after 1 week. And I'm going to write 7 days, after 7 days. All right, and I'm going to just put a bracket around this information, square bracket that. This is equal to, well, a sub 1 is going to represent my starting population or culture here, which is 5,000 bacteria. Another way of thinking about this is it's my initial value, so that's what I'm going to write down. So my initial value, or my starting value, times r to the xth power. So r is going to represent what's happening to my initial value, and my initial value is doubling. It's doubling, so let's change colors. So what's happening to this initial value? It's doubling, so it's doubling. And how long is it going to double? That's what we're really asking. So what's the duration? Well, it's going to double each day for a week, but for right now I'm just going to write duration of time, or duration here, just representing that this is going to double for a certain period of time. And I can just put a square bracket around that. Okay, so now this is helpful for me because now I can substitute values in for this function. So the first thing I'm going to do is just write it again as f of x. That's going to be my final value that I'm looking for, the bacteria after 7 days. Well, it's equal to that initial value. So what is that initial value? Well, the culture starts at 5,000 bacteria. So let's go ahead and write 5,000 here. So 5,000, I'm going to put that in parentheses, 5,000, and it's doubling, so let's go ahead and write times 2, 5,000 times 2, and it's doubling for a specific duration of time. It's doubling each day for 7 days, an entire period of 7 days. So let's go ahead and write 2 to the 7th power here. All right, so now you have 5,000 times 2 to the 7th. 2 to the 7th is 128. So times 128. And 5,000 times 128 is our next step. Well, f of x, so f of x here, what we're saying here, f of x, that's the bacteria, that culture after 7 days. Well, it's equal to 5,000 times 128. So it's equal to 640,000. And this is a good example here. This problem's an example of exponential growth. So what we're seeing here is exponential growth in this problem. Cool. I'll see you in another video.